Hello, so in this video we are going to talk through the homework for theme 3. So theme 3 was all about probability distributions and expectation and variance algebra as well. So as ever with this kind of video, you don't have to sit down and watch the entire video. If you're watching this on the YouTube site itself, you can always just skip forward to the relevant section that you need help with, so the relevant question, and the links are in the description below, but you can also kind of skip forward using the buffer button. Okay, so let's talk through question 1. So we're told that x and y are independent random variables. So I'm going to underline the word independent because I think that might be important later. Now we're given the fact that the expectation of x plus y is just simply the expectation of x plus the expectation of y. That is given to us. If you remember when we talked through the lecture, this is quite a gnarly proof, okay, which is not actually given to us in this course, and you don't need to know how to prove that. That will always be given to you as true, okay? So the expectation of x plus y is equal to the expectation of x plus the expectation of y. Kind of seems intuitive that should be true. And we're tasked to prove this fact. We're tasked to prove that the variance of these two random variables added together, so the variance of x plus y, should just be the variance of x plus the variance of y. Okay, so let's think about how we can do this. Well, first of all, I'm going to think about the formula for variance. So I'm just going to say, right, okay, let's take the variance of some random variable, okay? So I'm going to call it z, rather than confusing it with the x and y that we've got in the question. I'm just going to say, if I want to take the variance of some random variable, okay? Now, let's assume that this random variable is discrete random variable, in which case it will just be the sum of z minus the mean, all squared, times by the associated probability. And we talked through the reason why that should be true. I think it was in week 4 of the lectures, but you might need to go back and have a double check of that, okay? But effectively we said this should make sense, this should be true, okay? Now, if you fiddle around with this, you would basically notice that if you have the sum of something times by the associated probability, where that something is kind of to do with outcomes. So this z minus mu all squared, that's kind of to do with outcomes, because z is an outcome, and the mean, mu, and then I'm taking the difference and then squaring it, okay? This should be, by kind of default, because I know the sum of z times p is the expectation of z, then the sum of z minus mu all squared times p should just be the expectation of z minus mu all squared. This is kind of just noticing the pattern really there, okay? So this should be the expectation of that. Well, okay, if I kind of have a look at this then what I can basically say is I can just expand the thing inside the expectation out. So in other words, this should be equal to the expectation of, well, let's have a look. If I expand this z minus mu all squared out, it's just a simple binomial expansion. This is going to be z squared minus 2z mu plus mu squared, like so. Okay, so I'm just simply expanding that z minus mu all squared out. Okay. Now, if you notice, if I just use the fact that if I have the expectation of a sum of things, okay, then that should just be equal to the expectation of each individual thing. So let's have a think about that. So in other words, if I just distribute this expectation across of everything that I'm taking the expectation of, I should end up with, well, the expectation of z squared, okay, that makes sense, plus the expectation of negative 2, I'm going to write that as negative 2 mu times z, so I'm just going to swap the order around, and then plus the expectation of mu squared, okay? Now we need to think about what expectation means. It's basically saying, what value do you expect to get, okay? And knowing the fact that the expectation of a constant should just be a constant, okay? Then I can say, well, okay, I've still got the expectation of z squared there. Okay, well, the expectation of negative 2 mu times z, this is just expectation of algebra. It's a bit like saying the expectation of a times z, because the 2 and the mu are constant. Mu, remember, represents a mean. That's a mean value which is constant. So the expectation of negative 2 mu times z should just be negative 2 mu times the expectation of z. Okay, then I need to think, well, okay, what's the expectation of mu squared? Well, I'm basically saying if I have mu squared, which remember mu is just an average, so it's just a value, I'm squaring it, what value do I expect to get from a value? Well, it should just be that value there. It's not a variable, it doesn't change at all, okay? So therefore, that should just be mu squared like so. Well, okay, if you notice as well, well, look, the expectation of a random variable should just be, another way of writing that is the mean, okay? I could always write that the mean, mu, could just be the expectation of z. So when you see mu going on, just think of it, it's the expectation of z. So that means that I can make a substitution, and I can say that's equal to the expectation of z squared. And then I have negative 2 mu times by this thing here. Well, the expectation of z should just be mu, okay? We just said that up there. So in other words, I had negative 2 mu times mu. That should give me negative 2 mu squared, okay? Then I have plus mu squared there, all right? So that should give me the expectation of z squared. Well, okay, if I have negative 2 mu squared plus a mu squared, it's basically saying negative 2 of something plus 1 of something. That should just be negative mu squared. And if you notice that mu squared should just be the expectation of z squared, okay? So I can rewrite that as the expectation of z all squared like so, okay? So in other words, I'm able to show now that the variance of z should just be equal to, and I'll rub all this off, okay? It should just be equal to the expectation of some random variable squared, so in this case z squared, minus the expectation of z all squared, okay? So the thing is, I went through the proof. It's very, very simple. It's just expanding quadratics, then just thinking about what does expectation mean and being aware that mu just means expectation, okay? You're able to prove that the variance of z should just be the expectation of z squared take away the expectation of z all squared. Now, for this particular question, you didn't actually have to prove that. I'm just doing it for completeness because it is a show that question. So technically, I should take what I've been given, which in this case is the expectation of x plus y equals the expectation of x plus the expectation of y, and then anything else I have to prove. But to be honest with you, I'm not worried if you just use this as a fact because it's a standard result which we're just going to use from now on. Okay, so now I can actually focus on, okay, let's have a look at the variance of x plus y. Well, okay, in this case, I'm just saying that z is just x plus y, okay, because x plus y is just going to give me some value, and if I combine together, so basically what I'm saying here is take all of the outcomes for x, all the outcomes of y, add them all together, they're all variables, so I'm just going to say z is equal to that. Now that basically means that I should be able to write the variance of x plus y should just be equal to, well now I know that z is just x plus y, it should just be equal to the expectation of x plus y all squared minus the expectation of x plus y squared, like so. Okay, so I'm just simply substituting z equals x plus y in there to make sure I can make a comparison between this and this, okay? Now if you notice this, I have another quadratic that I can expand in here. So let's have a look at this. So I've got the expectation, well x plus y all squared is just going to be x squared plus 2xy plus y squared, like so, okay? And if you notice that the expectation of x plus y, well I can write that as the expectation of x plus the expectation of y. That's given to me in the question, okay? So this should just be take away the expectation of x plus the expectation of y all squared, okay? So I'm just simply thinking about what these things would be expanded out, okay? Now let's think about this. So hang on, I've got the expectation of loads of things being added together here. Well, just using the fact which is given in the question, just using this fact, if I have the expectation of a sum of random variables, that should just be equal to the expectation of each random variable added together. So that should just be equal to the expectation of x squared plus the expectation of 2xy plus the expectation of y squared. Take away, well okay, if I expand out the expectation of x plus the expectation of y all squared, this is going to give me the expectation of x squared plus 2 times the expectation of x, expectation of y, plus the expectation of y all squared, okay? And of course I'm going to subtract all of that as well. So let's have a little think about this. Well, all right, look, I've got the expectation of x squared. I can't really do much with that, okay? If you notice, I've got this term, which is the expectation of 2xy. Well, just using expectation of algebra, if I had the expectation of a times a random variable, like some constant times a random variable, then that should just be that constant times the expectation of the random variable. So in other words, this should just be 2 times by the expectation of xy, okay? Expectation of y squared, the next term, I can't do much with that. Now what I'm going to do, oops, let's make sure it's y squared. And let's also make sure this is x squared. Sorry, my brackets were around the wrong way, so that's really important, okay? So the expectation of each random variable like so. Now I'm going to distribute the negative over the bracket on the right-hand side. So this will be take away the expectation of x all squared. take away 2 times the expectation of x expectation of y minus the expectation of y all squared, okay? So I've just literally distributed the negative over that bracket. Now what I'm going to do is I'm actually going to pair some things up. So you notice all of the expectation of x, whether it's expectation of x squared or expectation of x all squared, I'm going to pair those together. So in other words, I end up with the expectation of x squared minus the expectation of x all squared. Okay. I'm also going to do the same with the y. So the expectation of y squared and take away the expectation of y all squared. I'm going to pair that together. So I've got plus the expectation of y squared minus the expectation of y all squared. And then whatever's left over. So in this case, I've got 2 times the expectation of x times y minus 2 times the expectation of x times the expectation of y. So I'm going to pair that together just by factoring a 2 out. So I have the expectation of xy minus the expectation of x times the expectation of y, okay? Now, let's have a look and see what we've got here. So effectively, this part here is just simply the variance of x. So the thing which I've just highlighted in red is just the variance of x. I'll write that in. That's the variance of x, okay? Because the expectation of x squared, take away the expectation of x all squared, that's basically the same thing as we proved right at the very start right here, okay? And you notice as well that the thing which I've got in green, okay, so the expectation of y squared, take away the expectation of y all squared, that is just simply the variance of y. And of course, I'm adding these two things together. Okay, so that's getting close to what I want. The issue is, however, I have plus 2 times this thing here in orange, okay, so this thing here. Now, this thing here is basically a measure of how x and y vary in relation to each other. So it looks a little bit like the expectation of z squared, because it's the expectation of z times z, or the expectation of 2 random variables times together, minus the expectation of z all squared. In other words, the expectation of z times the expectation of z. It's just in this case, the x and y. So it looks a little bit like variance, but because it's measuring 2 random variables, just the same, rather than the same random variable, we call it the covariance. Okay, so this thing here will be the covariance of x and y. It's literally just a measure of how x and y vary in relation to each other. Now, the great news is, if you have a look, x and y are independent variables. We've been given that in the question. Okay, so x and y are independent random variables. That means that if I want to measure how x and y vary in relation to each other, in other words, has x changed, how does y change? Then because they're independent, there shouldn't be any relationship between them, okay? In other words, as x changes, it doesn't affect how y has changed and vice versa. So because they're independent, that means there is no covariance. The covariance term just becomes 0. So I need to actually write that, because it's a show that question, I need to write that. So I just say since x and y are independent, that means the covariance of x and y should just be equal to 0. In other words, there's no variance, they don't change in relation to each other. Now that's really important, okay? You cannot just write covariance of x and y equals 0. You have to justify why, okay? You would not achieve full marks if you just wrote covariance of x and y equals 0. Therefore, what we're left with? Well, we're left with the variance of x plus y, which is where we started. Okay, that should be equal to, well, okay, we've got the variance of x plus the variance of y. Well, we've got those two things. Okay, so we've got the variance of x plus the variance of y. And of course, because they're independent, that term just disappears, okay? So you must make sure that you justify why the covariance of x and y is equal to 0. It's not enough just to say it is equal to 0. You need to justify to me. You need to show me why you understand why it's 0. You need to say they are independent, okay? Because then that implies that you understand roughly what the covariance is doing. It's measuring how one variable changes in response to another variable. So if they're independent, if one variable changes, it doesn't matter how the other variable changes. Okay, it's not going to affect each other. Okay, so that was question 1. Okay, so that was a nice little proof question, but you kind of need to just sit it through. It's not difficult. Okay, you can use that fact. Okay, you can either prove it, which some people did, which we did at the beginning as well, or you can actually just use it. I don't mind, but effectively it's just following your nose. It's just expanding loads of binomials, then just making a little justification at the end. Okay. All right, fantastic. So let's move on to question 2 then. So question 2, we've been given a probability mass function. So remember, probability mass functions are to do with discrete random variables, so it's only expecting specific outcomes within a given interval. And we've been given the probability mass function is given by this formula. So let me just talk a little bit, just in case you're unsure about how to interpret this. This basically says that f of y is just basically the probability that y is equal to some value. So y is our random variable, okay? And if you want the probability that y is equal to some value, then it's given by this formula. And there's 2 different cases you can have. The first case, the top line, is that the probability is just some constant, so k, we're told k is a positive constant down here. So some constant times that outcome squared, if that outcome is 1, 2 or 3. So in other words, if you want to calculate the outcome of either 1, 2 or 3, then you basically need to take k and times it by that outcome squared. Otherwise, so for all other values of y, it is equal to 0, okay? So that's how to interpret this function. Now we need to show that k is equal to 1/14. Now there's 2 different ways you can do a show that question. Number 1, you can use the fact that this is true. Okay, so if this is true, then you can use that to prove that something other logical statement must be true as well. That's perfectly fine for a show that question. In other words, you can use the k equals 1/14, use it somehow to show that some other logical statement is true, then just put a little justification at the end. That's not actually the way which I'm going to solve this question. It's not actually the way which I would recommend you to solve this question either. The way which I would do it is I'd say, assume this isn't true. Okay, so let's assume that we didn't know the value of k. Let's assume that the question instead said, find the value of k. Okay, so that's how I want you to think about the show that question. So I'm going to basically say to you, let's assume we didn't know that answer. It's kind of a checking the answer question, a show that question. Let's assume that wasn't true, okay? And let's use that, or let's say, now let's find the value of k. That's literally what the question is asking. So, okay, how could we use this probability mass function to find the value of k? Well, what do we know to be true? What do we know to be true about probabilities? Well, I don't know about you, but I know that all probabilities have to add up to 1. So let me write that down, okay? I know that the probabilities, if I add them all together, so the probability that y is equal to some particular value, if I add all of those probabilities together, that should be equal to 1. So let's start off there, okay? So let's think. Well, all values rather, for y, which are not 1, 2, 3, should all be 0. That's what the second line is telling us, okay? So second line literally says, if you have a value of y which is not 1 or 2 or 3, it basically means the probability of getting that value must be 0, okay? So therefore, the only real values we need to consider are this top line up here, okay? So basically, let's first of all consider the probability that y equals 1, okay? So in other words, the probability that y equals 1, so probability y equals 1, plus the probability that y equals 2, plus the probability that y equals 3, because these are the only 3 values that our value of y can take, which actually has some probability which is not 0. Otherwise, all values of y are 0. Well, if we add all those probabilities together, we should get 1. So now I just need to work out, well, okay, what is the probability that y equals 1? Well, surely I can just use this formula. That's literally what f of y tells us. It literally tells us what is the probability of getting some outcome. So this basically says, if I stick 1 in for y into my equation, so what probability equation should I use? I should use k times by y squared. So in this case, my y is 1, so I should get k times by 1 squared. That would be the probability that y equals 1. Then I need to add that to the probability that y equals 2. Well, okay, in that case, y equals 2. So I'm going to stick y equals 2 into my formula and then find what the probability is. So it's going to be k times by 2 squared. And then finally, for the probability of y equals 3, you guessed it, I'm just going to stick 3 for y into my formula. Okay, and I know that if I add those 3 things together, I should get 1. So let's play around with this. Well, 1 squared times k is just equal to k. 2 squared times k is 4k. And 3 squared times k is 9k. So therefore, if I add those 3 things on the left-hand side together, well, k plus 4k plus 9k is equal to 14k. So I get 14k is equal to 1. And if I want to solve this to find the value of k, because remember, I'm thinking about the question like that, find the value of k, just divide both sides by 14. Okay, so that gives me that k is equal to 1/14. So now if I have a peek at the original question, well, the original question says, show that k equals 1/14. I've assumed that I didn't know that. I just kind of followed a logical thought process, and I've got the answer, k equals 1/14. Hey, I'm in business, I'm done. Okay? Okay, so if we have a look at the part B, part 1 then, it's basically asking us to find the expectation of this random variable. So the expectation of this random variable, again, I'm going to use my probability mass function, which is up there boxed in the top, and I need to find the expectation of a discrete random variable. Well, just remind me, what's the formula for the expectation of a random variable? Well, the expectation of y should just simply be adding together each outcome times its associated probability. Okay, so expectation of y times p. So in this case, I'm going to add together y, and then how do I actually calculate p? Well, I just multiply it by whatever value of y I stick into this formula up here. So f of y is quite simply the probability that y is equal to that particular value. Okay, so let's do this. Well, let's think. There's only 3 values for y that we can take. We've just seen that in the last question, okay? So it can only take 1, 2, or 3. Otherwise, all probabilities for all the other questions are 0. So basically, I'll just end up with 0 times by some value, okay? Which is always going to be 0 anyway, so I don't need to consider it, okay? So let's do 1, 2, and 3. So, okay, I need to take 1, so value of y, which is 1, times by the probability that y equals y. Well, now I know k equals 1/14, okay? So just remember the way that these questions are structured, okay? Part A is a show that question. The reason why it's a show that question rather than find the value of k is because if you can't do part A, it doesn't then prevent you from doing part B. Okay, so the reason why it's set up as a show that question is that even if you couldn't do part A, if you couldn't show that k equals 1/14, that's okay. You can still use that value to answer part B successfully. Okay, so you're not penalised. So okay, we know that k equals 1/14, so I need to stick it into my probability formula to find out what the probability is when y equals 1. Well, that's nice and easy. It's just going to be k, which is 1/14, times by 1 squared. Okay, so it's going to be 1/14 times by 1 squared. Then I need to add that to my next value of y, which is 2, times by k, which is 1/14, times by 2 squared. So I'm literally just sticking values of y into this particular formula up here. Okay. Then the last value of y, which I can take, is 3. So therefore I'm going to add that to 3 times by 1/14, so k, times by 3 squared. So let's tidy this up. Let's see what we've actually got here. Okay, 1 times 1/14 times 1 squared is just 1/14. 2 times 1/14 times 2 squared. Well, 2 times 2 times 2 is 8. Times that by 1/14, that's going to be 8/14. Now, you could simplify that, I guess, to 4/7 if you wanted to, but I'm actually going to keep it as over 14th because I'm actually going to add all these things together later on. So it makes sense to keep the denominator the same. And then finally, 3 times 1/14 times 3 squared. Well, 3 cubed is 27, so it's going to be 27/14. So now if I tidy this up, I get 1/14 plus 8/14 plus 27/14. Well, I just need to add all those things together. So that's going to be 36/14. And just remember, when you're trying to find the expectation, it doesn't make sense to leave it as a fraction. A fraction is meaningless. Remember, you're literally asking the question, what value do you expect to get? So 36/14 doesn't really make sense in this context in statistics. So what I'm going to do instead is convert that to a decimal. So the way which I'm going to do that is just simply type 36/14 into my calculator, hit equals, it will bring it back up in simplified form, so 18/7, then just hit S to D, third to decimal, and that will convert that into a nice decimal number for me. So this is just going to be 2.57 to 2 decimal places. So I'm going to leave it as 2.57. So that there will be my final answer. So now doing B part 2, we just need to do a similar thing, but this time find the variance. Well, luckily enough, the formula for variance, let's just think, the formula for variance, there's a couple of different formulas. It's a discrete random variable, so I could use the sum of y may take away mean, square that and then times that by the probability of the outcome. What I'm actually going to use is the expectation of y squared minus the expectation of y all squared. Okay, so I'm going to use that. All right. So the way which I'm going to do this, let's first of all think, what is the sum of y? What is the expectation of y squared? Well, that's just going to be the sum of y squared times the probability of that outcome occurring. Okay, it's just simply the same kind of formula for the expectation. It's just you're replacing y in this case with y squared. Okay. And what's the expectation of y? Well, the expectation of y we've just calculated. We've just calculated that as 2.57 all squared. Now, just a word of warning, if you get this answer wrong, so if you get this answer wrong, you make a calculation error, it's not going to be an issue as long as you're consistent. So even if you get this part wrong, then actually, as long as you use the same value consistently and correctly for this part, you won't be penalised incorrectly there. So you've noticed this is worth 2 marks. If you get part B, part 1 wrong, you'll probably only get 1 mark, okay, or 0 marks, but then that doesn't prevent you from getting 2 marks down here either, okay? So we try and penalise you only once. We don't try and penalise you over and over again. So let's go through, okay? What is the sum of y squared times its associated probability? That's nice and easy, okay? Remember the only outcomes for y are 1, 2 and 3, and then I just times it by the associated probability by sticking in the relevant formula up here, knowing that k is equal to 1/14. So let's do that. Okay, so I'm going to take first of all 1 squared times by its associated probability, that's going to be 1/14 times by 1 squared. Then I'm going to add that to, well, my next outcome is 2, so it'll be 2 squared times 1/14 times 2 squared. And then finally my last outcome is 3, so I'm going to square that, times it by its associated probability, that's 1/14 times 3 squared. And don't forget that I still need to take away my 2.57 all squared. All right, fantastic. So you could, if you want to, just stick all that in a formula in your calculator. I personally, it's not going to take too much work for me to simplify it in my head. It's less buttons to type on my calculator, less places for me to go wrong. So let's just work this out. So we've got 1/14 plus, well, 2 squared times 2 squared is 4, so that's going to be 4/14. And then 3 squared times 3 squared, that's going to be 3 to the power of 4, which is going to be 81. So that's going to be 81/14. And I've still got to take away my 2.57 all squared as well. Now I'll just tidy up that fraction. Well, 1/14 plus 4/14 plus 81/14, that is going to be 86/14. And I'm going to take away my answer to the previous question, which is 2.57 for me, and square that. Okay, so I'm just gonna type all this in my calculator. So let's bring my calculator up. Now you noticed I haven't cleared my calculator from the last question. So even though yes, the expectation which I calculated was 2.57, that's what I've written down, I can actually reuse my answer from the previous question because it's still stored in my calculator. Okay, so that's a really good tip. Don't clear it. Okay, so what have I got then? Well, I've got 86/14, so I'll just type 86/14, so fraction 86/14, and then I need to take away the previous answer squared, because that's my expectation of y all squared. So I go answer squared, hit equals, that's going to give me a negative answer. So that doesn't seem quite right because I'm not expecting a negative answer there. So let me just go back and let me actually change this to what it should be, which was, I think it was 18/7, which is the expectation. So I can go 2.57, I'll just go 18/7. Okay, make sure I square all this, so stick it all in a bracket and then hit squared on that, hit equals, okay. Okay, so it's still coming up as negative, so let's just see what's going on here. I must have made a mistake somewhere. So I think I probably made a mistake when I've kind of gone through and done things in my head. So from here to here is when I've started to simplify my head. So let's have a look. So this is a kind of, alarm bells are ringing. I didn't expect that answer. So I'm going to go back and just have a quick check on what I've done. And I really recommend that you do the same if you're doing this in an exam. If you get something you don't expect, go back and do exactly the thought process I'm doing. So I'm expecting things to go wrong from here to here. So let's just go through and make sure I've checked and calculated each fraction correctly. So first of all, that 1/14, that makes sense. That's going to be 1 squared times 1 squared times by 1/14. That's 1/14. I agree with that. Let's have a look here. Hang on a minute. Have a look, I've made a slight calculation error, a little calculation error there, I was going too quick. 2 squared times 2 squared, well that's 4 times 4, isn't it? That's going to be 16, it's not 4/14, it's 16/14. So I suspect that's the issue, but I will just check the next fraction just to make sure. Right, 3 squared times 3 squared, that's 9 times 9, that's 81. So yeah, I'm happy that's 81/14. And obviously the 2.57 is the previous answer. So let's go back and actually recalculate this fraction. So 1 plus 16 plus 81, that's going to give me 82, 88, 98. Okay, that's a little bit bigger. That looks a little bit nicer, okay? So that should be 98/14. So let's go back to my calculator. Let's change this on the numerator to 98. Let's hit equals 19/14, 0.39. That's a lot more reasonable. I'm expecting a positive number for the variance. The variance can't be negative because remember it's a result of squaring values. Whole reason why I square distances from the mean is because I want to make values positive. So I shouldn't expect a negative answer at the end, okay? So therefore I can say that the final answer here should be 0.39. There we go. That's better. Okay, so that's the value for the variance. But I'm actually in many ways glad that I actually made that little calculation error because it gives you an opportunity to see two things. Number one, your teacher gets things wrong all the time. It's totally fine to get things wrong as long as you have that thought process in place to go, this doesn't make sense. And actually it also gives me a chance to illustrate when things do go wrong, the type of thought process that you should go through. Because at the end of the day, if you're sitting in an exam, high pressure situation, you're answering questions like this, you need to have your wits about you and that calmness about you to have a strategy to go back and methodically check through and think, okay, I suspect I probably make a mistake in there. That's a very high risk area. So then you can go back and check it. So just do exactly what I've done and you'll be absolutely fine, okay? All right, let's have a look at question 3 then. So we've been told the random variable x has a discrete uniform distribution. Remember, a uniform distribution basically says that the probability of each outcome should be the same, okay? And you can see that here. So the probability that x equals x, we're basically told it should be 1/5 for values of x of 1, 2, 3, 4, or 5. Otherwise, so for all other values of x, it's just 0, okay? So let's find the expectation of x then. So just remember, let's go through this quickly. It's very similar to what we were doing in the last question. Expectation of x, nice and easy. It's just going to be the sum of each outcome times its associated probability. Okay, so let's do this nice and easily, nice and quickly. So we're going to take x, which is 1 first of all, times it by its associated probability, which is 1/5. Then we're going to add that to the next outcome, which is 2 times by the associated probability, which is 1/5. And we keep on doing that right the way through to 5. So 3 times 1/5 plus 4 times 1/5 plus 5 times 1/5. All right, let's give this a quick calculation. Yeah, I'll do it in my head. I think I'm still confident. All right, so 1 times 1/5 is 1/5. Then we're going to add on 2/5, and then 3/5, and then 4/5, and then finally 1 or 5/5. Oops, let's do 4/5. And then finally 1 or 5/5. So let's give that a go. So okay, 1 plus 2 plus 3 plus 4 plus 5. 1 plus 2 is 3. Add another 3, that's 6. That's 10. That's 15/5. Okay. Which again, I don't want to leave it as 15/5. I want to leave it as a decimal. If you're okay converting from fractions to decimals like this in your head, I can do that. If not, you can stick it in your calculator. But that is going to be, that's going to be 3. Okay, because 15 divided by 5 is just 3. Okay, so that is going to be the expectation of x. Okay, nice and easy. Just use the formula and it falls out in the wash. All right, cool. So now we need to show that the variance of x is equal to 2. Well, I'm just going to use the variance formula. So the variance of x, remember, is just the expectation of x squared minus the expectation of x all squared. This is a much quicker formula to use than the formula which, the alternative formula for variance, in my opinion. So okay, the expectation of x squared, that's just going to be the sum of each outcome squared times the associated probability, minus the expectation of x, well that's 3, and we need to square it, okay? So let's do this. So sum of x squared times p, so we'll get 1 squared times 1/5, plus 2 squared times 1/5, plus 3 squared times 1/5, plus 4 squared times 1/5, and then finally plus 5 squared times 1/5. And we need to take away 3 squared. Well, I'm actually going to write that as take away 9. Okay, so I'm going to take away 9 here. All right, let's just go through and keep our wits about us. So 1 squared times 1/5 is just 1/5. 2 squared times 1/5 is 4/5. 3 squared times 1/5 is 9/5. 4 squared times 1/5 is 16/5. And 5 squared times 1/5 is 25/5. I need to take away 9 from this. Okay, so let's just quickly go through. Well, 1 plus 4 is going to be 5, plus 9 is going to be 14, plus 16 is going to be 30, plus 25, that's going to be 55/5. Take away 9. So, okay, let's bring up our calculator. Let's type that in. So we're going to have 55/5, which you could absolutely write as 11. Take away 9, that's going to be 11 take away 9. I should have done that in my head, it's 2, right? Okay. So there we go. The answer to that question there should be 2. Okay, so we'll get 2 as the variance. Okay, so I'll just make that a little bit smaller and then we'll move on to part B. Okay, cool. So let's move on to part B then. So, okay, we're going to find the value of the expectation of 3x minus 2. Well, basically, we're going to be using the expectation and variance values that we found up here. So I'll just write them in red in the top right-hand corner. So we found the expectation of our random variable was 3, and the variance of our random variable was 2. We found that in part A, okay? So now for part B, we need to find the expectation of 3x minus 2. Well, are you happy using the expectation algebra? This should just be 3 times the expectation of x minus 2. So let's think about this. It's going to be 3 times, well, the expectation of x is 3. Take that away from 2. So we get 3 times 3, which is 9. Take away 2, that's going to give us 7. So that's going to be our final answer there. Now, if I'm looking for the variance of 4 minus 3x, let's think about this. Now, it might make sense to write that the other way round. So I'm going to write this as the variance of negative 3x plus 4. That's the same thing, right? Then all I need to do is just think about what this means from an expectation or variance algebra point of view. So if I'm taking the variance of some constant value times x plus another value, then actually adding on that extra value, adding on that plus 4, what that's basically doing is just shifting the entire data set to the right by 4. So I'm just doing a shift. That shouldn't change the spread of the data set. That's what the variance is measuring. So actually the plus 4 won't change anything. However, it's going to be negative 3 squared times the variance of x. Because if you think about it, the standard deviation will be effectively multiplied by negative 3, because of course I'm making the data set negative 3 times as big. I'm doing a stretch of the data set. That's what's happening with the standard deviation, but the variance is just the standard deviation squared, which means I should take that negative 3 value, that negative 3 stretch or scale factor, and square it. So in other words, I should be calculating 9 times by the variance of x. Well, okay, the variance of x is just 2, so I need to do 9 times 2. That's going to give me 18. So that's the final answer for B part 2. So okay, let's move on to the next question then. So let's move on to question 4. So we've been given the discrete random variable x can only take the values 2, 3 or 4. And we're kind of given that here, I guess. Now, we've been actually given here the cumulative distribution function. So for the values 2, 3 or 4, we've been given the cumulative distribution function, which remember, f of x, a capital F now, okay? That's just going to be given as the probability that x is less than or equal to whatever value you're looking at. It's cumulative. It's added up all the way to that particular value. And we've been given the value, we've been given the function is x plus k all squared, all divided by 25. And we've been tasked to find the value of k, okay? Now just remember, this is just using exactly the same kind of principle as we did in question 2. I just need to use some kind of fact, some kind of rule that I know about probability functions and probabilities. Well, okay, I know that all probabilities have to add up to 1. So therefore, if I add together the probability that x equals 2, plus the probability that x equals 3, plus the probability that x equals 4, so let me write that down. So if I want to find the probability that x equals 2, plus the probability that x equals 3, plus the probability that x equals 4, if I add all of those values together, that should just be equal to 1. Now I could write this, if I like, as little f. So I could write that as little f of 2 plus little f of 3. Let me write that as a little f rather than a, I don't know what that was. Little f of 3 plus little f of 4, okay? So if I add together little f's of each of these values, that should give me 1. So remember, little f is the probability that x is equal to some value. Big F is the probability that x is less than or equal to some value. So we're actually looking at the big F in this case, the cumulative distribution function. So okay, think about it. If I want to look at f of 4, wouldn't that be all consecutive probabilities up until 4 added together? Isn't that literally what I've got here? Okay, so I'm adding together all of the different possible probabilities that I can have up until 4, okay? So in other words, this thing here should just be f of 4, okay? Because f of 4 is just going to be the probability that x is less than or equal to 4. In other words, the probability that x equals 2 plus the probability that x equals 3 plus the probability that x equals 4 added together, okay? So therefore, I know that that thing should just be equal to 1. So in other words, if I take this probability, this cumulative dense distribution function, the CDF, of this particular distribution, then I should just stick 4 in here and I should be able to use that to work out what k is. So okay, if I stick in 4, that should give me Well, in this case, my x is 4, so 4 plus k, all squared, divided by 25. I know that that should be equal to 1. Okay, so now if I just rearrange this and try and solve it, let's multiply both sides by 25, so I end up with 4 plus k, all squared, equals 25. If I square root both sides, I'll get 4 plus k is equal to, now just be really careful here, if I take the square root of 25 in this case, remember that I'm literally asking something squared must be given as 25. The answers for that has got to be plus or minus 5, okay? So not just 5, but positive or negative 5, okay? So in this case, I should end up with k, so 4 plus k equals plus or minus 5, okay? So let's treat each case separately. Well, okay, if I have positive 5 on the right-hand side, then I end up with 4 plus k equals positive 5. And on the right-hand side, if I take negative 5 on the right-hand side, I'll end up with 4 plus k equals negative 5. Now, I can solve each of those separately. So let's take away 4 from each side to solve the equations. So I end up with k equals 1, or k equals, well, negative 4 take away 4, negative 5 take away 4 is going to give me negative 9. So these are my two values of k. Now all I need to do is look at the question, and I'm told that k is a positive integer. So always look back to the question, okay? You notice as well it says value of k. There's only one value of k that it can take, okay? So if I left my answer like this right now, I would not achieve all 2 marks, okay? Because in order to get 2 marks, I need to say, well, okay, I know that k is positive, so let me write that down. So since k is a positive integer, then the only value of k which I can have, so negative 9 is negative, right? So it has to be 1. So k equals 1 is the only answer that I can have there. So if you just left your answer as k equals 1 or k equals negative 9, you would not score both marks. Equally, if you didn't go down this route of considering k as both positive 1 or negative 1, because you could have plus or minus, you would not score both marks either, okay? So to score both marks, you have to understand the fact that if you're coming from something squared equals 25, that something can either be 5 or negative 5, okay? So that's the first thing you need to identify. Okay, and then from that you need to identify the fact that k is strictly a positive integer, so no negative values allowed, and therefore the only value of k which I can take is 1. So let's have a look at part 2 then. So part 2, we actually need to find the probability distribution of x. So we've been given the cumulative distribution function, so that's f of x is, let me write it down here so we don't have to keep scrolling up and down. That's going to be x plus k all squared, and then I need to divide that by 25. Okay, so that's the cumulative distribution function. In other words, the probability that x is less than or equal to whatever value I'm sticking in. And the only values of x that I can take are 2, 3, and 4. Okay, so that's quite handy. There's only 3 values of x that I can take. And I need to use this fact to find the probability distribution of x. Now just remember, a probability distribution, you can write it in several different ways. You can absolutely write it as a function, like the probability distributions we've seen in question 2, 3, and also a form of it like here in question 4, okay? The other way that you can write it, and the way which I recommend that you write it, is just draw a table. So in other words, just have a table written out down here. So in here I'm going to have x, which is the outcome that I can have. And in the bottom row of the table, I'm going to have f of x, which is the probability that I can take for that particular value. And just remember, the only outcomes that I can have are 2, 3, and 4. So I'm going to fill that in along the top line of my table. Okay. Then the idea is I just want to fill this table in according to the probability of getting each particular outcome. Okay. So let's think how I can do that then. Well, okay. Are you happy that I need to work out, first of all, I need to work out f of 2. So f of 2 is just going to be the probability that x is equal to 2, okay? Then I need to work out f of 3, so that's just going to be the probability that x equals 3. And then finally I need to work out f of 4, which is just simply going to be the probability that x is equal to 4. So I need to work out these particular probabilities, the red, the blue, and the green. So let's go to the red one first of all. Let's work out the probability that x is equal to 2. Well, in order to work out that, I need to think about what the cumulative distribution function is doing. So the cumulative distribution function is just simply adding together all of the values up until whatever value I stick in. So in other words, if I stick in f of 2, that's going to be the probability that x is less than or equal to 2. Well, I know that any other value from 2, 3, and 4, that should be 0. So therefore, if I work out what the probability that x is less than or equal to 2 is going to be, so if I work out what the probability that x is less than or equal to 2 is going to be, well, because 2 is the only value that has a non-zero probability, all values below 2 are all 0, that should just be the same as the probability that x equals 2. Because probability that x equals 1, probability that x equals 0, probability that x equals -1, probability that x equals 0.5, they're all going to be 0. So it's going to be 0 plus 0 plus 0 plus 0 plus the probability that x equals 2, which is what I'm after. Okay, so in this case, I can just stick in f of 2. Okay, so I can just focus on f of 2. And that would give me the probability that x equals 2. So okay, if I stick 2 in this formula, I get 2 plus k. Well, I've just worked out k is equal to 1. Okay, I need to square it, and I need to divide by 25. So I worked out k equals 1 in the last question. If you get a different value for k in the last question, again, it's not an issue. Okay, just make sure that you're consistent. So you're using your value of k to stick in. If you didn't get a value for k in part 1, okay, then just say, assume k is equal to some value, okay? And that's fine. Then you can still answer part 2 and you won't lose any marks in this particular case, okay? So, okay, in this case, and I never usually write this, I never advocate writing across the line, it's just with slightly tight on space. So this case is going to be, well, 3 squared, which is 9, over 25, okay? So in this case, the probability that x equals 2 is going to be 9/25. Okay, fine. So now I need to work out the probability that x equals 3. Well, are you happy? I can't just work out the probability that x is less than or equal to 3, because that's going to be the probability that x equals 2 plus the probability that x equals 3. Okay, so this is going to be the probability that x equals 2 plus the probability that x equals 3. In other words, it's got a probability in there which I don't want. I just want the probability that x equals 3. But okay, given the fact that I know that the probability that x is less than or equal to 3 is the probability that x equals 2, so the probability that x equals 2, plus the probability that x equals 3, okay, I don't want this probability, I just want the probability that x is equal to 3. So therefore, if I take away the thing which I don't want from probability that x is less than or equal to 3, in which case I need to take away the probability that x is equal to 2, okay, then if I do that, then I'll just be left with the thing which I do want, okay? So actually in this case, I could even write this, just to make it a little bit clearer, as the probability that x is less than or equal to 2. So really, I'm getting to the essence of how to get the probability mass function from the cumulative distribution function. I just simply stick in f of whatever value I'm after. So in this case, I'm after f of 3. I don't know why I'm doing this in green, by the way, but I'm going to stick with it. So I'm going to just change this very quickly to blue. Okay, so let's change it to blue. Sorry, that makes sense. I'm doing the probability in blue. So I just simply need to stick in the f of whatever value I'm after. So I'm after f of 3, okay? And I need to take away all probabilities before that, okay? So I need to take away all probabilities up to the one before the value I'm just looking at, okay? So this is how to find the probability that x is equal to 3, okay? I just simply do the probability that x is less than or equal to 3, take away the probability that x is less than or equal to 2. The thing which I want is going to be left, okay? So, okay, let's stick this in then. So the probability that x is less than or equal to 3 is going to be 3 plus 1, all squared divided by 25. I'm just simply using the formula, okay? Then I'm going to take away the probability that x is less than or equal to 2. Well, that's just going to be 9/25. So I'm just going to take away 9/25 from that value. Let's work that out. So we've got 3 plus 1, which is 4. Square that, that's 16/25. And then I'm going to take away 9/25. So 16/25, take away 9/25 is going to give me 7/25. Okay, so that's the probability that x is equal to 3. Now, just to illustrate this again, there's a couple of ways that I can find the probability that x equals 4. I can either use the fact that all probabilities have got to add up to 1, so I can calculate the remaining probability. But just to show you that this works, I can basically find, well, okay, let's find f of 4, that's what I'm after, take away f of 3. Okay, so basically what I'm going to be left with is just the probability that x equals 4. So in that case, I'll get 4 plus 1, all squared, take away 25, take away the previous probability. Well, the previous probability was 7/25. So therefore, in that case, I get the probability that x equals 4 as quite simply 4 plus 1, which is 5, square it, 25. So that's 25, take away 7. That's going to give me the probability which I'm after, but actually I'm just going to use the fact that I know that all the probabilities down here have to add up to 1. So 9 plus 7, that's 16. So I need another 9 to make it up to the 25/25. So if I take that away from 1, I end up with that as 9 25ths like so. So that's nice and straightforward and easy to follow. So okay, let's have a look at question 5 then. So we're given a random variable and it has a distribution which is binomial. So binomial, so just remember binomial distribution has two parameters. It has n, which is the number of trials, and p, which is the probability of success. So let's have a look at this then, okay? So if we know the random variable x has this distribution, okay? So we're not actually given what the probability is in this case. We're told that the number of trials is 12, that's given as the first parameter, but we don't actually know what the probability of success is. It's just given as p. Now we've been given that the probability of getting no successes, the probability that x equals 0, been given that probability is 0.05. Can we find the value of p correct to 3 decimal places? Yes, we can. Let's just remember, what is the probability that x is equal to some particular value? Well, okay, that's just quite simply the number of ways of choosing that many successes from the number of trials that we're doing, times it by the probability of success that many times, so the number of successes we're interested in, times it by the number of failures for the remaining number of trials. Okay, so that would be the probability that x is equal to some particular value. So if I just stick in this case, r is equal to 0, okay, so the probability that x equals 0, I can use this probability mass function in the top right hand corner to work this out. So okay, number of trials is 12, number of successes is 0, so 12 choose 0. Probability of success we don't know, so I'm going to leave that as p, okay. Number of successes is 0. Then the number of failures. Now I'm going to write number of failures I'm going to write it as 1 minus p, okay, as the probability of failure rather than q. And then the power is going to be, well, there's going to be 12 failures, aren't there? Okay, because it's going to be 12 minus 0, okay? So basically what I'm doing, if I solve this, well look, 12 choose 0. How many different ways are there of choosing 0 things from 12 possible objects? Or 0 successes from 12 possible trials? That's just 1, okay? So I get 1 times by p to the power of 0, well that's 1, so I know that both of those things are 1, okay? So that's 1 and that's 1. So in other words, I just need to look at that thing there. So when I simplify this, this is just going to be equal to 1 minus p, all raised to the power of 12, and I know that that is equal to, so I know that that is equal to 0.05, okay? So I know that's equal to 0.05, that's given in the question. So now I just need to solve this equation, try and find out what p is. Well, I guess the first thing to do is to take the 12th root of 0.05, so 12th root of 0.05. I think that's a calculator job. So let's bring my calculator up. So I'm looking for an empty square root. Now the empty square root button is actually here, okay, just above the empty power button. So to get it, I'm going to shift, press that button, okay. That brings up my empty square root. Now you can see my cursor is looking for what root I'm after. So in this case, I'm after the 12th root. Then I just press to the right to find what my probability is. So in this case, it's 0.05. Hit equals, and I get that as that, okay. Now just remember, that is 1 minus p. Okay, so 1 minus p is equal to, and I'll abbreviate here, is going to be 0.78, all right? So therefore, to find p, I'm just going to have to do 1 minus this thing, so 0.78. Now, I'm not actually going to type 1 minus 0.78 in my calculator because I want it correct to 3 decimal places, okay? So I'm just going to do 1 minus answer on my calculator, and that's going to give me to 3 decimal places rather, 0.221. So that is going to be my value of p if I know that the probability of getting no successes is 0.05. So that would be the probability of success. It's about 22% chance, okay? Let's have a look at part B then. So we're given instead that the variance of x equals 1.92. Now find the value of p if that has to be true. So just remember, how do we calculate the variance of a binomial distribution? Because remember, x is binomially distributed. So to work out the variance, it's just simply n times p times q. So the number of trials times the probability of success times the probability of failure. Okay, and we prove that in the lecture. So let's work this through. So n in this case is 12. Probability of success we don't know, so I'm going to leave that as p. And the probability of failure, again, we don't know, so I'm going to leave that as 1 minus p. Okay, but we do know that the variance is equal to 1.92. So we know that all of this thing is equal to 1.92. Okay, so in other words, this is the equation which I'm going to have to solve. All right, so let's have a look at this then. So first things first, what I'm going to do is I'm actually going to expand out this left-hand side, okay? So I've got 12p times by 1 minus p. So if I expand that out, I get 12p minus 12p squared. Okay, so 12p times by everything in the bracket, I just distribute the 12p over the things in the bracket, and I get 12p minus 12p squared, and I get that as 1.92. Okay, now it's an awkward thing to try and solve, but I can see it starting to look like a quadratic. So because I know how to solve a quadratic, I need to set things equal to 0. So I'm going to add 12p squared to both sides, and I'm also going to take away 12p from both sides. And I know that is equal to 0. Now this looks like a horrible quadratic to try and solve, okay? I could try and actually convert that into a fraction, so 1.92. If I just hit 1.92 on my calculator, hit equals, okay, that's a little bit better. So that brings up 48 over 25. So I'm actually going to rewrite this as 12p squared minus 12p plus 48 over 25 equals 0. And then what I can do is just multiply everything by 25. Well, okay, what's 12 times 25? Well, 12 times 25 is going to give me 300. So in other words, I get 300p squared minus 300p plus 48 equals 0. All right, what's 300 divided by 48? How many times can I cancel that down? All right, I think I can probably cancel it down 4 times maybe, because 150, 75, yeah, that would work. So I can cancel everything down 4 times, so divide everything through by 4. Effectively what I'm doing is working with a quadratic. You could absolutely just work here and stick it straight in the quadratic formula, but I'm trying to avoid using the quadratic formula just to show you, okay? So let's divide everything by 4, so I get 75p squared minus 75p plus, right, 48 divided by 4, that's 12, isn't it? Equals 0, okay? And actually I could also divide by 3, couldn't I here? So I could go 25p squared minus 25p plus 4 equals 0. Okay, so now I just need to work out, right, how can I get this thing to factorize? So I'm going to try and just do this this sort of straight off. So let's have a go at this, shall we? All right, so I'm looking for 2 numbers that multiply together to make 25 times 4. That's going to be 100. And they need to add together to make my negative 25. Okay, I think 20 and 5, maybe negative 20 and negative 5, that would work. So I'm going to split this negative 25p into negative 20p minus 5p, that's what I said, didn't I? And everything else stays the same, so I get 25p squared plus 4 equals 0. Split it down the middle, let's see what we get. So if I factorize out a 5 from each of these, so 5p, and I get 5p minus 4, that would work, wouldn't it? And then I need 5p minus 4 on this side. Hey, this is working nicely, equals 0. This is going to be minus 1. So that's going to factorize to 5p, take away 1. Times by, what's that going to be, 5p take away 4 equals 0. So that means if I solve this thing that p must be equal to a fifth, or p must be equal to, well, 4 over 5. So if I want to leave that as a decimal, I can say that p has got to be equal to 0.2, or p is equal to 0.8. So that's the value of p which you're after. Now, by the way, I did that in my head. I guess I was showing off a little bit in some respects, but if ultimately I just wanted to avoid using the quadratic formula, I kind of knew, because I knew the answer, that this wasn't going to factorize, or it was going to factorize, so I was going to try and show you how to factorize it by hand. But to be honest with you, if you just wanted to state this and just stick it in the quadratic formula, so negative b plus or minus square root of b squared minus 4ac, all divided by 2a, where a is equal to 12, b is equal to negative 12, and c is equal to 1.92. Stick all that in your calculator and you'll get the same answer. So to be honest with you, it doesn't matter which method you use. I just wanted to show you that it does factorize. Now the thing is, it's always good practice to assess, does these answers actually make sense? So p equals 0.2 or p equals 0.8. I think those are both valid answers for probabilities, okay? If I was going to get a value outside of the range of 0 to 1, then those values of p are no longer allowed. They can't have a value outside of the range of 0 to 1. But both 0.2, 0.8, they both lie within the range which we're after. That's all good. You also notice in the question, it's talking about values. It's plural, okay? So therefore, I'm looking for more than one. So that's totally fine, okay? All right, let's finish this off. Let's have a look at question 6. So question 6 says that in a restaurant, an average of 70% of customers asked for water with their meal. A random sample of 15 customers is selected. Now I want to try and derive a probability distribution here, okay? So I'm going to say that x is equal to, let's say, the number of customers who asked for water. Who asked for water. Okay, so number of customers for water. Okay, and I think this sounds very much like a binomial distribution. Let's check it. Is it independent? So are all trials independent of each other? In other words, if one customer asks for water, is that necessarily going to affect another customer asking for water? No, I don't think it is. So I think they are independent, okay? Also, is there a probability of success? Yes, there is. I've got a 70%. I've got a proportion there, okay? So I know that X is probably going to be binomially distributed. Let's just check our last condition. Is it success or failure? Yes, it is. They either ask for water or they don't ask for water. So in this case, I'm looking at a sample of 15 customers. So that's like my trials, okay? 15 customers. Each customer is a different trial. What's the probability of success? What's the probability of them actually asking for water? That's going to be 70% or 0.7 if you prefer, okay? Now, I've been told that exactly 8 customers ask for water for their meal, and I need to find the probability of that happening. So what's the probability that the number of customers asking for water, so probability that X, is equal to 8? Well, in that case, I just simply use the binomial probability mass function. So that's going to be n, which is 15, choose the number of things I'm interested in, which is 8 successes, times the probability of success, which is 0.7, 8 times, times the probability of failure, which is 0.3, for the remaining, well, okay, in this case, I've got 15 customers, so that's going to be for remaining 7 times. So let's just stick all that in my calculator, because I can't be bothered to calculate it, so it's going to be 15, choose, remember the choose function is just above the divide, so it's 15 choose 8, times that by 0.7 to the power of 8, times that by 0.3 to the power of 7, hit equals, oops, I've made a bit of a mistake there, just make sure I get out of that power, okay, so times by 0.3 to the power of 7, hit that equals, and I get my 0.0811. So I'm going to write that as down, 0.0811. Good practice, always write probabilities when you're working with them to 4 decimal places, and then you can always write them as a percentage if you want as well. I am going to write as a percentage, it's more meaningful, and also my probability to start off with has also been written as a percentage as well. So this is going to be 8.11%, okay? Now I need to find the probability that less than 13 customers ask for water with their meal. So in other words, what's the probability that X is less than 13? Well, I'm not going to do probability that X equals 1, plus probability that X equals 2, plus probability that X equals 3, plus probability that X equals 0. I forgot the probability that X equals 0. It's a common mistake. Don't forget probability that X equals 0. So probability that X equals 0, probability that X equals 1, X equals 2, X equals 3, X equals 4, right the way up to 12, because I don't want to include the 13. That's long, okay? I'm just going to look at the probabilities I don't want, because there's only 15 customers I'm going to ask, so I think it's easier to look for what is the probability that more than or equal to 13 customers ask for water with their meal. Do 1 minus that and I'll be left with the probability I want. So let's have a look at this. This is going to be 1 minus probability that X is equal to 13 plus probability that X is equal to 14 plus probability that X is equal to 15. All right, good. So I need to just basically calculate each of those probabilities individually. Now I could absolutely just use exactly the same probability mass function as I used up here for each of these 3 different cases, but I'm actually going to show you a slightly quicker way of doing this. So what you can do if you have access to a computer, okay, what you can do is you can come to GeoGebra.org, okay, and basically if I come down here to GeoGebra Classics, completely free to use, and you see there's a few different options over here. I'm going to select probability. And what I'm going to do is I'm going to go to this drop down arrow and I'm going to select my binomial distribution. So I've got binomial, Poisson, etc. I want binomial distribution here. I need to select the number of trials. So I need to type in here the number of trials, which is 15. I need to type the probability of success, which in this case is 0.7. Then basically I can choose either less than, values between, or probability of values greater than. So in this case I want the greater than probabilities. You notice that on the right hand side I've got greater than of all the probabilities automatically being calculated for me. So I'm going to take 0.0916. So if we come back to my whiteboard, I'm going to take 1 minus 0.0916. And then the probability that X is equal to 14 I've got as 0.0305. And the probability that X is equal to 15 I've got 0.0047. So 0.0047. So I could absolutely just read those probabilities off directly. Or actually what I'm just going to do is I'm going to get GeoGebra to do it automatically for me. So I'm going to change the probability that x is greater than or equal to 13 there. And you notice it just brings up 13, 14 and 15, just highlights the probabilities I want. And it'll tell me if you add those probabilities together, it's going to be 0.1268. Okay, so this is going to be 1 minus 0.1268. So if I take that away from each other, let's bring up my calculator to do that to make sure we're proper. So 1 minus 0.1268. If I hit equals, I get myself 0.8732. So that might be a slightly quicker way just to check it. Now just be aware, because I know that we're going to be doing open book exams in the future. If you're not doing open book exams, then obviously you need to calculate these directly because you won't have access to things like GeoGebra. But certainly for doing things like homework, we're actually just doing this, calculating each of these probabilities individually. It's just very long and laborious, and actually it's not really getting what I want to assess, okay? But if you are going to use something like GeoGebra, okay, please make sure that you write down these probabilities, okay? I need to be able to see that you understand what's actually happening here, okay? So just please make sure you write down enough working so that I can still award marks. At the end of the day, I'm not interested in your ability to use GeoGebra. That's not what I'm assessing, okay? What I'm assessing here is, do you understand what's happening, all right? All right, let's have a look at part B. So I need to now find the expectation of X. I need to find the expected number of customers to ask for water at their meal. Well, very easily, to calculate the expectation of a binomial distribution, I take the number of trials and multiply it with the probability of success. So in this case, the number of trials is 15 and the probability of success is 0.7. So if I multiply these two things together, I just simply do 15 times 0.7 on my calculator, hit equals, and it brings back 21 over 2, which is 10.5. Hang on a minute, can I have 10.5 as the expectation? Short answer is not really, because they're discrete and you're talking about the expected number of customers. So you're like, we can't have half the customer. But in this case, I'm fine for you to leave it as 10.5, okay? So I'm not really too worried, as long as you're aware that it doesn't actually really make that much sense. But to be honest with you, because it's just a calculation, it's just the theory going on in the background, you know, I just want you to interpret it as somewhere between either 10 or 11, okay? So you can call it 10, call it 11, that's kind of the expectation. It's around 10 or 11 customers, okay? All right, let's finish this off with question 7 then. So this is the final question which I asked you. So we've been told patients arrive at a hospital at a rate of 6 per hour. So I need to write down my probability distribution. Now, because it's a rate of success, I know I'm going to be looking at a Poisson distribution. So in this case, I need to define my random variable very, very carefully. I'm going to say that X is a random variable that represents the number of patients that arrive, so the number of patients. And remember, if you're using a Poisson distribution, you must always give me the time period, or you must always give me the interval that you're interested in looking at. So in this case, it's not just the number of patients, it's the number of patients in an hour, okay? So in 60 minutes. So you must always define what the time period is when you're defining the random variable. This is particularly true. So good practice, always define what your random variable is, then you're clear, okay? If you just go ahead and just answer the question, dive into this particular question here, you probably won't get full marks, okay? But it's particularly important to define your random variable when you are working with Poisson distribution, because the definition of a random variable with a Poisson distribution, it has that time interval baked in, okay? Because you're looking at a rate of success, it has that time interval baked in, so you must tell me what that random variable is defined at, otherwise you won't get full marks. So actually in this case, what is the rate of success? Well, we're given it in the question, so it's distributed using a Poisson distribution, and it's a rate of 6 per hour. Now always remember, the way which we write the Poisson distribution is with a PO rather than just P. Reason being is because P is already used for probability. This is not probability, this is a Poisson distribution, okay? Now we need to find the probability that during any 90-minute period, this is interesting. So now we're looking at a 90-minute period. So our definition of our random variable for X is a 60-minute period, but we're changing it because we're now looking at a 90-minute period. So let's use a new random variable now. So Y is, instead of it's going to be the number of patients in 60 minutes, it's going to be the number of patients in 90 minutes instead. So that's really important. If you change the time interval, you need to change the definition of your random variable. Now hopefully you can see why it's really, really important to write down what your random variable is defined as, okay? Now, what is my random variable for y? Well, y is distributed again, still using a Poisson distribution, but the rate is no longer 6 because 6 corresponds to 60 minutes, okay? So therefore, to find the rate for 90 minutes, I'm just going to have to divide by 60 and times by 90. Okay, so divide by 60, get it for 1 minute, times by 90, get it for 90 minutes. So that's going to be 9. So I'm expecting 9 patients per hour for this particular distribution. Okay. Now, I need to find the probability that I get exactly 7 patients in a 90-minute period. So what is the probability that y now, not x, y, because I'm talking about the number of patients in a 90-minute period, is equal to 7, okay? So let's think about this. Well, okay, what is the probability mass function for a Poisson distribution? So what is the probability? What is the probability that x is equal to some particular value? Well, that is just simply saying it's just going to be the rate, which is lambda, to the power of the number of successes you're interested in, okay, or the number of patients you're interested in, times by e to the negative lambda, e to the negative rate, all divided by r factorial, the probability you're after, the outcome you're after, factorial, okay? So let's use that probability mass function here. So in this case, my rate is 9, because I'm looking at the 90-minute period. I'm going to raise that to the power of 7. I'm going to take e to the negative 9, all divided by 7 factorial. So I'm just simply sticking the numbers in the correct place in my probability mass function. Let's see how this looks on a calculator. So I'm going to clear my calculator. I'm going to first of all hit my fraction button, and I'm going to go 9 to the power of 7. Hit to the right to make sure I come down out of the power. Then I'm going to go e, so e is found up here. So I'm going to go shift and then log, and then it's going to be negative 9. Then I need to go down the denominator, so I'm going to press the down button, and I need to go 7 factorial, so it's going to be shift. Where's the factorial button? There it is, just there. Okay, so it might take a little bit of hunting around to find the correct numbers on the calculator, but I basically find that is 0.1171, or approximately 11.7%. Okay, so that's the probability that during any 90-minute period that I will get 7 patients arriving is about 11.7%, or about 12%. Now I need to find the probability that it's at least 3. So again, I'm still looking at y, I'm still looking at the number of patients in a 90-minute period, but I want it to be at least 3. At least 3 basically means I could have 3, or 4, or 5, or 6, or 7, as long as I have at least 3 patients arriving. So in other words, at least 3 is literally saying 3 or more. Okay, so 3 or more. Okay, that means at least 3. Okay, so therefore I could do 3, probability that y equals 3, plus probability that y equals 4, plus y equals 5, plus y equals 6, etc., etc., etc. The issue is this is not like a binomial distribution. Remember, a Poisson distribution, you don't have a fixed number of trials. So you know you can only have integers like 0, 1, 2, 3, 4, 5, 6, etc. Because it's discrete. But in this case, you don't have a fixed number of trials. So if I do 3 plus 4 plus 5 plus 6 plus 7 plus 7 plus 8, do all the probabilities of those particular outcomes, I don't know where I'm going to end up. I need to keep going right the way to infinity. And it just so happens that eventually those probabilities become 0 anyway, or close to 0, but there's still a chance that it could happen. So actually in this case, what I'm going to do is I'm going to flip it around. I think it's easier to look at the probability that y is less than 3 instead. So I'm going to look at the other case, the probability that y is less than 3. So in that case, I just need to do 1 minus, well, that's going to be the probability that y equals 0. Don't forget the probability of y equals 0. It's a common mistake people make. You can have no patients arriving. That's totally allowed, okay? Plus the probability that y equals 1, plus the probability that y equals 2, okay? Because I don't want 3 in this case, okay? I want, just strictly speaking, less than 3. So again, I could absolutely go through, use my probability mass function, so use this probability mass function here and find out probability that y equals 0, y equals 1, y equals 2, etc. But I think because I'm feeling a little bit lazy, I'm not interested in sticking all those things in a calculator. I'm just simply interested in calculating each of those probabilities. So again, I can come to Desmos and I can change this to be a Poisson distribution instead. And I want the rate, so the mu in this case is the rate, so we say lambda to be rate, they're just using mu to be rate. And in this case, the rate is going to be, what was it? The rate was going to be 9, okay, so it's going to be 9 there. All right, so therefore I can find the probabilities I'm after here. So I'm after the probability that it's going to be greater than or equal to 3, so I could absolutely just drag this line across and move it to 3, okay? Then it will give me the probability automatically, so 0.9938. You can actually see here, look, as soon as I get to probability of like 21, or probability that y equals 22 or 23 or 24, etc., you can see those probabilities are so small it's basically zero. There is a probability there, it's not quite zero, there is still a probability there, it's just the probability is so small that we can basically just say it's very, very unlikely to happen. It's basically zero, okay? So that's what I was talking about. To find the probability that y is greater than or equal to 3, eventually those probabilities will just drop off to zero. But the issue is, if you're just calculating it by hand, you need to go through enough times until you get to probabilities which are basically zero anyway. So in this case, I'm looking for probabilities that's strictly speaking less than 3. So I want less than or equal to 2, so either 0, 1 or 2. And if you have a look, I've basically got probabilities here. So I'm going to write these 3 probabilities that are shaded down. So probability that y equals 0 is 0.0001. So probability that x equals 0 or y equals 0 is 0.0001. Probability that y equals 1, well, I've got that as 0.0011. So it's going to be 0.0011. And probability that y equals 2, that's going to be 0.005. So it's going to be 0.005. All right, fantastic. So therefore, it's going to be 1 minus all of that lot. So I need to do 1 minus, well, if I add all those things together, fortunately, GeoGebra tells me down here that that should be 0.0062. So again, I'm writing enough working down so that if somebody else is going to view my work and mark it, like I am as a teacher or your marker, they're able to see exactly where you get these numbers from. So if I now do 1 minus that, let's bring up our calculator. Oops. Let's bring up a calculator. So I'm going to do 1 minus 0.0062 here equals, and I find that comes out as 99.38%. So it's a pretty high percentage, right? So it's going to come out as 0.9938, or about 99%. So 99.38%. Okay, so that's a probability of at least 3. Okay. So let's have a look at the last question then. So if you've watched all the video up until now, we're there. We're at the last question finally. So well done for making it this far, okay? So we're told that a patient arrives at the hospital at 11:30 a.m. Now, can you find the probability that the next patient arrives before 11:45? So in this case, what's the time interval we're looking at? Well, we're looking from 11:30 to 11:45. That's a 15-minute interval. So I need to redefine my random variable, because so far I've got a random variable x defined as the number of patients in 60 minutes. I've got a random variable y, which is the number of patients in 90 minutes. I want the number of patients in a 15-minute interval. So I'm going to create a new random variable. I'm going to say it's z, and this will correspond to the number of patients arriving at the hospital in a 15-minute window. Okay. So let's think about what the rate is going to be. So it's still going to be a Poisson distribution. But this time, what's the rate going to be? Well, okay, the rate for 60 minutes was 6. The rate for 90 minutes was 9. So the rate for 50 minutes, I just need to take the rate for 60 minutes, which is 6, and just divide it by 4. That's going to get me to 15 minutes there. So if I take 6 and divide it by 4, that's going to be 1.5. So I'm basically expecting 1.5 patients to arrive in that 15-minute interval. Now, admittedly, 1.5 patients doesn't really make sense because it's discrete. You can't have half a patient, okay, unless they've had a really serious accident. But in this case, we're going to say 1.5 is the rate, because then we'll be able to work out what we need from there, okay? Now, we want to find the probability. Let's look at the wording of the question, because I think this is slightly awkward wording, so we just need to think a little bit. So what's the probability that the next patient arrives before 11:45? So basically, we're saying that a patient arrives at the hospital at 11:30. We want to make sure that another patient arrives before the 11:45 window cutoff, so for the next 15 minutes. So just think, all we want there is for there to be one patient or more. Okay, because all we're interested in is just the next patient arriving before 11:45. Okay, so as long as there's one patient, at least one patient arriving before 11:45, we're golden, we're in business. Okay, so we don't care about whether there's 2 or 3 or 4 or 5, that's all great. Okay, all we care about is that there's at least one patient. So what we're actually looking for here is, what is the probability that z is greater than or equal to 1? Now, if you were looking at this question, if you were thinking, oh, I know the answer to this, I'm just basically looking for the probability that z is equal to 1. That is not correct, okay? And let me try and justify why. We want 1 or more rather than the probability that z equals 1, okay? Because we don't just want the probability that z equals 1. Let's think about this, okay? Because this should always be, we should always think about complements with situations like this, okay? So let's just think, what situation don't we want? Okay, what situation don't we want? Well, if we want to find the probability that the next patient arrives, we basically want at least one patient arriving before the 15-minute window is up, then the situation we don't want is for no patients to arrive. Okay, so in other words, in this case, this should be 1 minus the complement. Well, in this case, the situation we don't want is for no patients to arrive. Okay, so this is the very situation we do not want. The situation we don't want is for no patients to arrive. Otherwise, well, it's the situation we want. Okay, so always think about the complement if you can't quite convince yourself of that. Because are you happy now that the probability that z is equal to 1 is not equal to 1 minus the situation we don't want? In other words, the situation of no patients arriving. So if you're not sure about the wording, always sometimes think about the complement. Think about what situation you don't want, do 1 minus the situation you don't want, you'll be left with the situation you do want. So therefore, in this case, we are definitely looking for the probability that z is greater than or equal to 1. Okay, well, this is actually fairly easy to calculate. I don't need to go to GeoGebra or anything like this. So if we just calculate z is equal to 1, probability that z equal to 1, I need to take the rate, which is 1.5, raise it to the power I'm interested in. I need to times that by e to the negative rate, so e to the negative 1.5, and I need to divide that by the thing which I'm interested in, which is 0 factorial. So effectively, this is just going to be 1 minus e to the negative 1.5. Now, if you're looking at this and going, hang on a minute, if I'm dividing by 0 factorial, I can't do that. I can't divide by 0. Well, just remember, 0 factorial is just 1. Okay, I can show you that very, very quickly because I realise that 3 factorial is just 3 times 2 times 1. 2 factorial is just 2 times 1. So in other words, what have I done to get from 3 factorial to 2 factorial? Well, can you see I've just effectively divided by 3. To get to 1 factorial, well, that's just 1, so effectively I've just divided by 2. So if I follow the pattern down, to get to 0 factorial, well, I should just divide by 1. So 1 divided by 1 is just 1. So therefore, 0 factorial is just equal to 1. So don't worry about the fact you're dividing by 0 factorial, because it's equal to 1, not 0, which is what most people get confused with. So let's have a look at this then. So 1 minus e to the negative 1.5. Let's stick that in a calculator and let's be done with this. So let's do 1 minus e, which is that button, to the negative. So let's hit the negative button. Let's be proper here. Let's go 1.5, hit ourselves equals, and we get 0.7768. So it's going to be 1 minus, well, we've done the 1 minus, haven't we? So it's going to be 0.7768, which is approximately 78%. So 77.68%. So either one of those is fine. So what I really would stress here is when you are dealing with any distribution, always give the definition of the random variable. So actually say, what does z represent? What does x represent? What does y represent? Now, it's okay for binomial and sort of other distributions because it's kind of implied what you mean here, but definitely for Poisson distributions, because you have got the interval baked in, you've got the time period baked into that definition, you must give what you've defined your random variable as, because otherwise you will not get full marks, okay? It's very, very difficult to answer the question otherwise, okay?